In this video we'll go on with number 45, and we're looking for all relative extrema and using the second derivative test wherever we can. So 45, we have g of x is equal to x squared times 6 minus x to the third power. G prime of x, we'll have to use a product rule here, so we have 1. d2 will be 3 times 6 minus x to the second power, times the derivative of the inside function, which is -1. So that's 1 d2 plus 2, which is 6 minus x to the third power, 2 d1, which is 2x. So let's simplify this up a bit. We get negative 3x squared times 6 minus x to the second plus 2x times 6 minus x to the third. We'll factor out the least common multiple, which is 6 minus x to the second. That leaves negative 3x squared plus 2x times 6 minus x. We multiply two numbers with the same base, we add exponents. So 2 plus what equals 3? 2 plus 1 equals 3. 6 minus x to the second power, we have negative 3x squared plus 12x minus 2x squared. We end up with 6 minus x squared. 6 minus x. Quantity squared times negative 5x squared plus 12x. And then we can factor out an x from that. Let's factor out a negative x from that. 6 minus x squared, and leaving us with 5x minus 12. And I think that this is a fine example of we can tell everything we need to know using the first derivative only, which we have here. And at this point, to find the second derivative is so much work and so not worth the effort just to find the relative mins and maxes. So I am going to stop at that point, and our zeros are x equals 0, x equals 6, and x equals 12/5. Alright, so we're going to make a sign chart here with our three critical numbers at 0, at 12/5, which is about 2 and 2.4, 12/5, and then at x equals 6 over here. So this is roughly 2.4. So we'll have -1, 1, 3, and 7. And we'll plug these values in to the first derivative and see what we get. We have -1, negative times negative is positive. Then 6 minus -1, that's positive also. And -5 minus 12 will be negative. So positive, positive, negative is negative. Plugging in 1, I have negative, positive, negative. So that will be negative times negative is positive. 3, I have negative, positive, and positive. So that will be negative. Plugging in 7, I have negative, I have positive, and finally positive. So negative, positive, positive will be negative as well. So from this we can see that we have decreasing, increasing, decreasing, and decreasing. We're going to have a relative max, relative min rather, at x equals 0, relative max at x equals 12/5. And we can plug these values back into the original function to get their the corresponding y values. But x equals 0 should be y equals 0. 12/5, I'm not even going to worry about that. And that will do it. That finds the two relative extrema that we have at 0 and at 12/5. Now notice why at 6 there is none. Well, because at 6 we are squaring 6 minus x, that factor is being squared, which means that to the left and right of that are both going to be the same value. So if we had negative coming in, well, they're both going to be positive, I should say. The fact is that whenever you have a multiplicity of 2 like that, that root will not be a minimum or a maximum. We'll get what happens here. We either have negative, negative, decreasing, decreasing, or increasing, increasing. And what that looks like is something like that, or something like that, where we go from decreasing to decreasing, or increasing to increasing. Now we can actually take a graph of this, and so we have x squared times 6 minus x to the third and we'll zoom standard and see what we get. Well, we have a crazy graph here. So I'll work on the window, and there. We needed to fix the window up quite a bit. Turns out that I go from -5 to 5 on x's, -100 to +500 in steps of 100 on the y's. And so there, though, we can see that we have the minimum at x is equal to, actually this is not going to be sufficient because we don't see what's happening at x equals 6. I'm going to expand this again. Alright, that's better. I go from -2 to +10, and I'll take a picture of this and put it on the workspace. And we can see exactly what happens when we have that multiplicity of 2 at x equals 6. The function goes from decreasing to decreasing, and we don't have a relative min there or max. We had a relative max at x equals 12/5, and we had a relative min at x equals 0. So x equals 6 is neither. 12/5 is a max, and 0 is a min. So hopefully that makes sense there, and we're going to have enough of this. The moral of this story is you use the second derivative test when it's easy to use. In this particular case, it would have been much more work to do the second derivative test, and there's no point in doing it in that case.